Good afternoon, everyone. Thanks for coming to this session on REST and GraphQL and Java and Spring. And I think he's already done an introduction, so I don't need to do anything except say that I'm also a Java champion, among other things. The last one is my favorite, the Perl recovery group. How many people still code in Perl today? Anybody? Okay, so a few people, yeah. We're going to meet at 6:30 for beers in the Perl recovery group downstairs, so anyways. One thing quick I want to say is that if you're not familiar with what IBM does in the Spring world, we do lots and lots of different things. Spring works really well on IBM Cloud, and we have an amazing runtime called OpenJ9, which is a drop-in substitution for Adopt OpenJDK and the Hotspot VM. So especially OpenJ9, it uses less memory and starts up faster, and lots of other stuff. But come by the IBM booth, get a free t-shirt like this, and come hang out with us. And obviously, we're going to have beverages sponsored by IBM later today. So before I get started, I just want to take a quick survey. How many people are currently using GraphQL? Okay, so a few people. How many people are using it with Java on the back end? GraphQL server, okay. Now, what I want to do is do a quick introduction to GraphQL and then look at an implementation of GraphQL written with two different libraries that help you build out a GraphQL solution on Java on the server side. So let's talk about GraphQL a little bit. The first thing about GraphQL is that it is actually a query language, right? That's what GraphQL stands for, Graph Query Language. So it's very similar to how we do programming in the Java world, where when we're building an inheritance model using Java classes, we're essentially building out an object graph, right? We sometimes call it a tree, but it is actually a graph when you're doing object-oriented programming. So GraphQL actually can mirror the way that we build applications with domain-driven design and domain-driven development quite well, because it matches up to the way that we already build applications in the Java world using OO design, okay? Now, you might be thinking, well, we have to learn another language. Fortunately, GraphQL is very simple and straightforward. There's not much difference in terms of the way that we think as object-oriented Java developers already. But yes, it is a new language and it is a new specification, so it takes a little bit of time to understand some of the nuances around it and how to build things with it. And I hope to do that in the next 47 minutes here today. Okay? So, the other thing to note is that GraphQL is an API query language, and the key word there being API, okay? So the emphasis on GraphQL is around building APIs. And as we go through and do some demos, you'll see hopefully how that works in terms of going and building out GraphQL queries and how they relate to an API that you're building behind it, okay? So GraphQL was created by Facebook and it was open sourced in 2015. And it has been maintained as part of essentially a community effort now. And it is, more than anything else, it's a specification. There's not a implementation or a reference implementation of GraphQL. Okay, so it's more specification than an implementation. And when we do some demos and code here in a few minutes, what we're going to see is implementations of the GraphQL specification on the server side. Because that's one thing important to note, that it is actually a spec and not an implementation. So how many people watch Silicon Valley in here? Is that, okay, so good. I wasn't sure if it was just us in America who watch it. But anyways, this is a scene from Silicon Valley. So you might be thinking, we just rewrote all of our APIs or endpoints or whatever using REST. And now I'm up here telling you that you should look at something like GraphQL, right? And maybe you're feeling like the guys in this picture. We should just burn it all down. And why do we bother, right? So, yes, you may have rewritten everything in REST, or maybe you're in the process of moving over to a more RESTful-based API and architecture. But the nice thing about GraphQL is that it is not a pure replacement for REST. The way that I like to think about it is that GraphQL is just another tool in your tool belt for building applications. So you don't have to throw away everything that you've written in REST. You can happily coexist with REST and with GraphQL on the same server or in the same architecture. You can use both if you want, which is really nice. Okay? We'll get into that a little bit as well in a few minutes. And one of the things you can actually do is that if you already have RESTful APIs, especially if you have a RESTful distributed API that's in multiple different endpoints or multiple different servers or services, or however you've designed your architecture, you can actually wrap your underlying RESTful APIs with GraphQL on top. And this is actually a very powerful abstraction because you can have multiple teams that are building things. Maybe they already have built things in REST. They have APIs exposed in REST. You can actually go and just wrap them and create like a meta API on top of existing APIs so that your front-end applications or your mobile applications have a single unified entry point into all these different disparate APIs and data sources. And again, we'll get into that in a few minutes as well. All right, so as mentioned already, we can have any data source underneath. And in fact, with GraphQL, because it's just a specification for the front end or from the front to the back end, it doesn't even have to be a data source. It doesn't have to be a database in the back. You can have something else running in the background and wrap that with a GraphQL API, which is actually super powerful, okay? So we'll look at that as well in a minute. Now, one thing that's different about GraphQL compared to RESTful endpoints is that it is a single endpoint. So when you set up a GraphQL instance, it will only go to one place, right? /GraphQL or whatever you want to call it. And the other interesting thing about GraphQL compared to REST is that it is schema-based, right? We'll have a look at a GraphQL schema in a minute when we go and explore what it actually looks like. But these are the two key differences, and we'll talk about more, but the two key differences between GraphQL and standard REST is that there's a single endpoint instead of multiple endpoints. You know, when you're building out a RESTful endpoint, you may have a /users endpoint, and you may have /shopping cart or /items or whatever, so you have different endpoints. With GraphQL, you only have one endpoint, and you send a query in to get the exact data that you need. And there is a schema behind it, so instead of being something that you just construct on the fly, and you say, well, this is our user's endpoint, and we have the 4 verbs, HTTP verbs, to get and post and put, etc. GraphQL can take either get or post, but single endpoint, and we pass it a query to see what it looks like. And we're going to do that now. Okay? It's time for a quick demo. And you know how demos work, so hopefully this works well. All right. So let's have a quick look at a few queries here. And hopefully that's big enough. Let's double check. Yeah, it should be fine. All right. So what I have here, first we start with query, and we say all starships, get me the starships underneath, and the name and the model. And you can see that's printed here, but let's go and actually amend to that, and let's see what we can do. Let's say what class of starship is that. And let's go run this. And you can see that now we get the starship class as Corvette, and this is a destroyer. Of course, this is from Star Wars. But let's see what other data points we can add here. Okay, and you can see as I'm working through this, this is what's called graphical or GraphQL, which is a browser for an underlying GraphQL endpoint. Okay, so we can say, let's see how big the different types of starships are. So you can see these are the length. Of course, a Star Destroyer is much bigger than a CR-90 Corvette. Now, let's actually see how we can go look at this in a little bit more detail. So what we can actually do is, because GraphQL produces a schema, we can actually go look at the schema. And if you have a developer who's not on your backend team where the GraphQL is actually produced, your front-end developer, whether a mobile or web developer, can actually come here into this GraphQL Explorer for your GraphQL endpoint and have a look at actually what all is exposed through your GraphQL API. Right? So you can see that in this specific demonstration API, we've so far been looking at starships. So if I go down to starships, here's the starship relation, and I can click into here, and we can go look at what are the different types of things under that. Right? So we have starships and all of the schema that is associated with that specific type of starship. Right? So we can see here's a description of all the different fields which are made available to us. So we have name, model, class, who's the manufacturer. Let's go see who makes the manufacturers. Right? And again, because we have a predefined schema on this, we have this tool which allows us to go and browse and inspect and look at this specific GraphQL endpoint that we have. So we can come into here and we can say, who are the different manufacturers of that? Let's get rid of this for now. Right? Now if we go run this, you'll see that we can go and see that these are the different types of people who make that Star Wars starship. Right? But let's go back here real quick, and we should be able to also see what films that specific starship appeared in. So again, we're just browsing the GraphQL schema here using this tool called GraphQL or GraphQL, and we can see all the different things which are contained in it, but if we scroll down a little bit, we can also see that there's this something called film connection. So now if I go into film connection, we can see that there's basically different types of films that are associated with each starship. So I can come into here, and I'm not going to try to type this all out right now, right? So I'm going to go and run this specific thing. It's the same as before. Let's query all the starships. Let's get the name and model. And now we're saying let's traverse a relationship called film connection, which is a one-to-many relationship in this case. Remember, GraphQL is a schema. It's different than SQL. It's not the same thing as SQL or SQL. It's more of a graph-based schema rather than a relational schema. But in this case, we have a relationship from starship into films right here. So let's go run this, and we'll see that the CR-90 Corvette appeared, the first movie it appeared in was A New Hope, and then the Star Destroyer also appeared in A New Hope. And let's scroll down to see if we can find a different one, right? So the Imperial Shuttle first appeared in The Empire Strikes Back. Now, the way I was able to get the first one is I used an attribute here called first that said, give me the first film that starship appeared in. So I can put 2 here and go run that, and now we'll see that, for example, the Star Destroyer appears in A New Hope and also in The Empire Strikes Back. Now, if I get rid of this altogether, you can probably guess what's going to happen, right? It'll show me all the films that specific starship appeared in. Okay? So what we're doing is we're just very simply using the GraphQL query language, exploring what we can do with the GraphQL endpoint. All right, so let's do a couple of extra ones here. So we did this first one with the film connection. We can also go get the count, so I can say query all starships count, and I'm going to go run that, and you can see that doesn't work. Why doesn't that work? It says in the message that cannot query field count on starship, do you mean total connection? So let's go put that in. And actually, I didn't need to go and look at the error message. I could have just come into here, and when I hit Control Space, it shows me all of the attributes or the fields that I have access to, which is really nice. So if you have a new developer who's come onto your project, into your company, and they're the front-end developer, or even if they're a back-end developer, you can just say, just go browse the GraphQL endpoint to learn all the different things we expose. In some way, this can also serve as documentation. How many people love writing documentation in here? Anybody? Okay, this room must be full of developers, because me as a developer, I hate writing documentation, but you have to do it, right? But this is great, because from the schema, we can get this documentation essentially for free, okay? Anyways, so let's see and go run this, and this database has a total of 37 starships inside of it, right? So the other thing we can do, which is interesting, is that we can go and get something from one collection, the starships collection, and in the same call also get something that's totally unrelated. So the different species in the Star Wars world has nothing to do with the different starships, right? They're totally different. So I can go and run this, and at the top, I'll get all my starships. So let's just collapse all the starships, and then right underneath it, you'll see that I have a list of all the species in the Star Wars universe. So I'm basically going and fetching 2 collections in the same database, or in the same GraphQL call. Right? And I'll tell you about why this is important in a few minutes. But essentially, I'm able to go get 2 different unrelated collections which are inside of my schema in the same API call. Okay, and we already looked at how we can do collections, traversal from starships into films, right? This is a one-to-many relationship, of course, or maybe a many-to-many relationship, because probably different starships appeared in different films and vice versa. All right, so the other thing we can do is, when we're constructing this, right, so the query is just a string that we're doing. So say we're using a JavaScript front end. How many people build front end in JavaScript as well? Just out of curiosity, right? So a fair number of people. So when we're building this in JavaScript, how do we do this? There's some libraries that help you build GraphQL queries in JavaScript, and similarly for iOS and Android. But we don't want to do like string concatenation and string construction when we want to reuse a query over and over again. So you might say, inside of my application, I want to go and get the starship multiple times, right? But I want to get different ones. And we don't want to come in here and do string concatenation, or, for example, let me go find the right one. I have it here somewhere, or maybe I don't, right? So I may not want to go and actually get and hard code the actual name of the starship inside of my application. Of course, I can't find it. I've written it earlier. There it is. Oh, not that one. All right. Anyways, so what we can do is we can use essentially query parameters like we have in this example. So what we do is when we construct GraphQL on the client, we can say, here are my query variables. I'm going to call it Starship ID with this specific ID. And then in my GraphQL query, I can say $Starship ID. Again, that's this thing right here, right? And we give it a type of ID exclamation point. So this is the other thing about GraphQL, which is interesting, is that not only do we define the structure of our data, or of our schema, we also put in the specific type that each field and each data element is. So in this case, we're saying that this Starship ID is of type ID, and then we're able to go and use that to go and fetch a specific starship like so. Okay? So we looked at how to traverse relationships, how to use query parameters, how to use pagination and modifiers like first, so that we can just get a page of data if we want, and other things like that. All right, oops. All right, so let's go back to here, not now. All right, so let's make sure we covered everything. We talked about how we can traverse a relationship, like so. We talked about how we can get a count, and how we can do a query. This is what I was looking for earlier, right? So we don't want to hard code the ID like we have here. We'd rather use a query variable so that we can reuse the same string and go and get a result out of it, right? And then we did this as well. How do we use query variables? Now, if you noticed when we were inside of our GraphQL queries, let's go back to this one right here. Okay, let's find the simpler one, right? So like this, or if we look at this, you can see that I had to type everything out. Let's say Starship class, manufacturers, oops, and I keep hitting the wrong button for some reason. Okay, sorry. Costing credits, and maybe we'll do the length, and et cetera, right? But in GraphQL, you do have to go and type every single field that you want. You can't just say star. There's no wildcard parameter in GraphQL, right? So like in REST, you can just say, go get me all the user info, and you get all the user info, right? How can you get every field in an object? The short answer is that in GraphQL, you cannot. You have to be explicit about which specific fields you want from a specific object. Now, it's actually a deliberate thing that there's no wildcard to get everything. You have to specify every field that you want in a GraphQL object that is in the schema. That is actually by design and not on purpose. So at this point, you're probably thinking, well, if we're going and having to type every field every time we want to go get it, is this a good thing, or is it an anti-pattern, or is it just bad, or are you just ready to leave and just stay on rest? Well, the reason why, and they shut the lights off. Can you still see me in the dark? Is that okay? All right. So I don't want to stand there the whole time. All right. So this is actually a good thing, because there are a couple of things that it enforces. Number one, you only get what you ask for. So you don't get everything. Say that you have a really big object that you're exposing to your RESTful endpoint. You don't go and get everything, right? And that's actually a good thing. And the other thing with GraphQL, as you saw previously, is that I can go get things from two unrelated objects in the same call. Sometimes when you're building out the front end for an application, and you need two different things from two different places, and you have a RESTful endpoint, how do you go get those two different things? You have to make two API calls, right? You have to reach back to the server and say, I want all the user info, and now I want all the item info, but you have to make two different calls because they're in two different RESTful endpoints. With GraphQL, you can just make one call and go get everything, which is great. All right? So the two specific things that GraphQL has in terms of advantages over REST are the two things I just talked about. The first thing is what we call overfetching. I just want these 3 fields from the user object and not the other 10 fields which are there. In GraphQL, you have to be explicit and say, go get me the user info, go get me the user info, and just go get me these 2 things. Right? So in REST, that problem is known as overfetching. Also in REST, there's something known as underfetching. I need something from the starships collection and from the species collection. And they're not related, so in REST, I'd have to go make a call for my starships and a call for my species, so I'm making 2 calls instead of 1. So GraphQL solves that by allowing you to fetch different collections inside the same query, i.e. it fixes the underfetching problem. Okay, so these are the 2 key advantages of GraphQL over a RESTful endpoint. The other thing is that, for those of you who raised your hands, who are JavaScript front-end people, you know that when you make a network call and you immediately make a network call, you're nesting 2 network calls, and in JavaScript, that's asynchronous, so you have to nest them, and you start getting into what we call callback hell in asynchronous environments. In GraphQL, you can avoid that because you just make call and get 2 different things from 2 different data sets if you want. Right? Also, just like we're able to go and fetch from 2 different unconnected objects, we can also go update 2 unconnected objects in the same network call. So it's a variation of the underfetching problem, where we can make a GraphQL query that does a mutation. That's what it's called in GraphQL, to go and change an object inside of the endpoint and say, go and change this object, and at the same time, change this other object. Okay? So GraphQL is quote-unquote faster, and GraphQL is quote-unquote simpler. Now, I have that in quotes because that's not necessarily always the case, right? There are times when GraphQL is actually slower than a RESTful endpoint, and there are times that REST is actually simpler than a GraphQL endpoint. But in general, as you're building out and doing API design, you will find that GraphQL, on the whole, is a little bit faster, or sometimes much faster, and also simpler than REST, but not always. All right, so let's talk about wildcards a little bit more. Right? So another reason why it's actually nice to be explicit about what you specifically are getting from the endpoint is, say that someone on the team over here removed a field from the object. Right? You weren't expecting it. Maybe you're working on another team, or maybe you're working on the front end. Right? Or maybe you're a server-side engineer and you want to play a joke on your front-end engineer or something, right? So if you remove a field, what happens in REST? It's just not there anymore, right? Or what happens when you add a field onto an object? In REST, it just automatically now shows up, right? So both of those are problems. Now, if I go back to my GraphQL editor here, or graphical, okay? Let's say that this field, costing credits, was removed. Or let's just make up a field. Let's say that a field called home planet was removed from our backend. Now, when I go run this query, you'll see that it gives me some weird error for some reason, okay? Well, anyways, the point here is that it actually gives you an error. Let's actually try something. Let's get rid of this. Simplify this a little bit. I'm missing a bracket, aren't I? Thank you. Okay, let's try now. There we go. Thank you. All right. So let's say that we used to have a field called home planet. Well, when I'm looking at this in graphical, you can see it actually says that. But if I actually run it, what do we get? We actually get an error. So if we have some kind of unit or integration test, how many people don't write tests for their software? Okay, there's a couple of hands over there. I applaud your style. I have a T-shirt that says, I don't normally test, but when I test on production. So, right, it's a big hit at conferences. Anyways, the point here is that because we have a schema, and that schema is rigid in some ways. Well, rigid isn't the right word. It's very well defined. If you remove a field, you will get an error on the front end. Your GraphQL query will no longer work because it'll give you this error. Your server side will return something and say, I don't know what field you're talking about. Okay? And the other part of this is that when we add a field, we may not want to go get it in our existing queries. Right? So before I showed, for example, this film connection here. Right? And this film connection may be like a really large object that's embedded inside of another object. And say a server-side engineer adds that new field in that has this massive data behind it, and now all of a sudden in your RESTful endpoint, you just wanted the user info. Now you're pulling in the whole item catalog or whatever is a related field to it. Right? That's also bad because that causes a big performance problem or other problems. So Actually, being explicit in the fields that are there and the fields that are removed and fields that are added is actually a good thing because it enforces good design. It enforces good API design, okay? Now, a lot of the stuff that we do in REST is kind of like magic, right? We have, let's just go get the user info, let's go get this and that, whatever. So one of the things we avoid with GraphQL is we avoid that magic. It's a little bit more concrete what we're working on. So with the not having the wildcard, the app breaks in obvious ways, and we don't overfetch on new relationships that may be very large, and that's very important, right? But you might be thinking, oh, it's such a pain for me to have to type out every field every time I want to go get that user info or item object or whatever. Maybe it has 20 or 30 or 50 fields inside of it. And it's such a pain typing them over and over again. Well, what we can do is we can use something called fragments to help alleviate this pain in GraphQL. Right? What does a fragment look like? Say we have something like users. So we would create a fragment called user fragment that would contain some basic field data that we want to get maybe every time we use it. So you can see I have a fragment called user fragment here. And then when I want to go use that user fragment, you can see on the bottom I say fetch users, user with I2, and then I do ... user fragment. So that uses that user fragment, then you can reuse that fragment in the different places where you need to go get the same set of fields every time, so you don't have to type them out over and over again. Okay? All right, and we'll get into this a bit later, but how do we actually go and change data? So far we've only gone into how do we query data out of GraphQL, and this is what you do for mutation. We'll look at that in just a minute. Okay? Actually, we're going to jump to our code here and talk about GraphQL in Java. So there are two main libraries for doing stuff. There's one called GraphQL Java, which is a very low-level library for building GraphQL stuff out. We'll have a look at that in a second. And there's another one called GraphQL SPQR, or pronounced Speaker, which is a GraphQL library which is a little bit more sophisticated for building out a GraphQL server. And I like diagrams, so I put this one together that shows you how you do a diagram, or how you do GraphQL or where it sits. So you still have your database, or it could be anything else. You can still use JDBC and JPA, and then you have GraphQL on top of it, which makes your endpoint, which is what your client would actually then use. Okay? And the data can be anything, right? So we're going to use it, just a H2 in-memory RDBMS for this demo, but it can be anything. You can expose something off the file system if you want it, or if you have some kind of network server, if you have a Redis server that has like transitory information, like just stored in memory, you can expose that through GraphQL. You can expose anything you want. It's not necessarily just a database behind it, okay? So when we're defining an API, and we can wrap anything you want. Okay, that's one of the great things about GraphQL. And again, let's jump into our demo. We have about 21 minutes, so I'm going to speed things up a little bit. And this is our first demo here, okay? So in this one, I'm just using the standard GraphQL Java API. So we need to have a couple of different things, but let's start with our domain object. So you can see I have my @entity, so this is just standard JPA, and here is my annotations for all those different things, right? Standard entity object, book, and author, okay? So we have two different annotations or entities here. Okay, let's just make sure, right? And every book has an author, so we say, here's our author relationship from book, and these are just standard repositories, so you can probably guess what this is if I open this up. This is just a CRUD repository, and again, just a CRUD repository. Is everyone familiar with Spring Data repositories, like JPA and CRUD repositories? Yeah? Okay, is this a spring conference? Okay, just making sure. So you probably know what this is, so I won't spend any time on that. Right? What I want to spend time on is let's have a look at the actual application. So what we have is this is an error handler. We'll look at this error handler in just a second, but you can see if we go up here, this is the standard Spring Boot application right here, okay? And now I have a couple beans defined here, a book resolver, a query resolver, a mutation resolver, and this is just a command line runner for doing some testing. But let's go actually have a look at those. And again, those are just beans that get injected into our GraphQL server. So let's start with query, and we take the repositories like so, and we have find all books and find all authors, and that goes and queries the repositories, and we have count book and count authors. Okay, so our query basically implements this GraphQL GraphQL Query Resolver object. So this is, when you're using this specific library, this is the entry point for our GraphQL server. So we basically create this query object that implements GraphQL runner, or sorry, GraphQL Resolver, and we go and define these specific operations to go and look at this. So let's go start this up from the command line, make sure this works. I think I already have it running. Okay, great. So let's go into here, and let's just run count books really quickly, right? So you can see we have one book in here right now. I'm just going to comment this out. And now I'm going to run find all books, like so. Let's go run that, and you can see I currently have one book in our database. And if we remember, find all books and count books, and go into our query class, which implements GraphQL Query Resolver, you can see I have find all books, find all authors, count books, count authors. So if I change that, if I were to change this from find all books to find authors, it would return that. Okay, but let's go look at the resolver really quickly and what the resolver looks like. So I have book resolver, implements GraphQL resolver, and you can see underneath the hood, it basically goes and gets the author repository. And the reason why we need this resolver is because our book has a relationship to another object we wish to expose through GraphQL called author. So we have to set up this resolver so from within our query for find all books, it can go and figure out where that underlying contained object is, right? And if we wanted to save a author, we would create a mutation which implements GraphQL mutation resolver, and then it goes, exposes something called new book. So if I come into here, and let me just comment this out for now, right? Comment it out. And if I were to come here and say, what was it called again? New book? All right, so I'm going to be lazy and just say, ooh, that's not right. Why did that happen? Uh-oh. I think my command key got stuck. Okay, I'm going to skip that demo for now. But anyways, this is how we do it. Now, I don't want to spend too much time on this because while this is good for building like a low-level API, unfortunately, there's a lot of work that needs to be done. Right? One of the reasons we use Spring and things like microprofile with annotations and CDI and all those things is because we don't want to write all this code. We want to spend as little time writing this code as possible. How many people like to write lots of code, by the way? Anybody? No. Why don't we like to write a lot of code? Because the more code you write, the more code you have to test, and the more code can potentially have bugs and break down, right? So that's why we like to use Spring, because we can write less code. So the library I prefer to do it, you do this, is called GraphQL Speaker, which uses annotations so that we have to write less of this kind of boilerplate and have less ceremony to do this kind of stuff. So let's have a quick look at another sample project that uses this other library. Okay, so let's start with our basic object. And in this case, because I really don't want to write code in this project, I'm using what's called Project Lombok, which you can see is imported here, but it gives me annotations like this, so I don't have to write all the getters and setters and all that stuff. How many people use Project Lombok in here? Just out of curiosity. Okay, good. I think everybody's hand went up, so I won't explain that part. All right, but you can see I have my @entity object here, and then I say, oh, @GraphQL Query, name is ID, description, blah, 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 private long ID, GraphQL Query, name, blah, blah, blah. So instead of having to write those resolvers and other things like that, I basically just put an annotation on a field and say, this field is now queryable, right? This is great. So less work I have to do. So now, we look at our car service, nothing fancy in here, but I have get car by ID, and this is where, so in here, I say, go and allow this thing to be queryable. And now if I go into my car service, which has my cars, like so, right, I can say get car by ID, name ID, etc. Go and find from the repository object that car. And also, you can see it's annotated with @GraphQL Query for car. So this is our root entry point into the car object. But I've also defined a mutation called @GraphQL mutation. The name of that mutation is car, save car, right? So it can be different than the actual name of the method if I want. And it takes in a type of this specific car, and you can see there's some extra annotations in here. And I call the underlying GraphQL repository. Let's go run this, make sure it works real quick. Okay, let's quit out of here. And do a Spring Boot run on this real quick. Let's see if this is working. Okay. Okay, come on. Setting up the database and everything, so it might take a second. And you can see I'm just injecting in some initial values for us to play around with. Okay, so let's go again to our graphical. Let's do a reload. And oops, I think I ran that mutation. I didn't mean to do that. Okay, so let's go look at our cars, and let's make sure this works. Uh-oh. Oh, thank God it worked. Okay. But if you remember from this output right here, I just for testing, I inserted this into the memory database Ferrari, Jaguar, Porsche, blah, 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 blah. So it looks like I have 9 things. So I should have 9 cars here. And now, if we go back to our code really quickly, we were calling the car, right? So this is the name that I actually referenced right here for cars, right? Oh, I'm sorry. I was getting a list of cars. So GraphQL Query name equals cars is basically running this line of code in our server, okay? Now, the great thing about this is that we just go and annotate things and say, this is the entry point for my cars object, which gives me a list of cars. And this is my car over here, my car object for getting a specific car. And because we have strong typing in Java and all the stuff is there, we basically, our GraphQL schema is auto-generated for us by just inserting these annotations into the appropriate places, which is really nice. That means it's less work for us to do. And again, we get this nice API browser called GraphQL, and we can go browse the docs here. So we can say, let's go look at the entry point for query, and here's cars, and it contains a type of car, and that car has a Giphy URL, ID, is cool, and name. So if I go back to my code, you can see that we have some additional stuff. Well, that's interesting. Where is this Giphy URL coming from? Okay. So it's not in my car object. So where's that where's that Giphy URL? If you remember what I said earlier, GraphQL is just a specification for building out an API. And we have to build out that API as developers. So in this case, what I'm doing is I'm using my car entity object as the base, let's say the base object, and then I could just add in some random crap to it if I want, okay? So let's go search in this code base for a Giphy URL. Where is that thing? Oops, it helps so I can type Giphy URL. Okay, there's something called Giphy service here. So that's the string, okay. So let's go here. And now, again, I'm in my car service. All right, so if I zoom in here, you can see I'm in car service. And now if I scroll down a little bit, you can see I have this thing called Giphy URL. Right, so what I'm actually doing is I'm saying that in the context of this car object, go and add an extra field, which is not part of that actual entity, which we're basically just adding it, like dynamically, if you will, as part of the query mechanism in GraphQL. So we're saying, go get the Giphy URL, right? And what this is doing then underneath the hood, it's using this Giphy service, which goes and makes a call to Giphy and gets us back the actual URL, right? I don't need to show that part. But the point here is that, again, we don't just wrap a simple entity object or just a Java class or something. What we can do is we can actually just add something or anything. In this case, I go and make a call to the Giphy service, which is here, and I go and attach that data to that actual object at runtime in this car service, okay? So it's just a demo of like, it can be very flexible, and you can do all sorts of crazy or useful things even to go and build out this API. So let's go back to our API browser here. So you can see that we have these Giphy URLs and everything, okay? Now, let's say we want to add a car. All right, so let's go, I'm just going to comment this out for now. All right, so let's go and add something. Okay, so I'm going to say mutation, save car, Tesla Model S Extreme. Well, the Tesla 3 just came out. We'll add that in a minute. ID, name, etc. Okay, so ID will get auto-generated. We have to provide a name, which we do right here. So here's car, name, . Now, let's go look at this specific thing. Let's go find the save car in here, okay? Let's do F, save car. Oh, here it is, save car. And you can see it takes a car type, but it expects it to be wrapped inside of some kind of car container thingamajig. And we pass that down into here, Right, so let's go run that really quickly. Okay, so we got the data back, and now if, right, and again, a mutation is how we make a change or essentially do something like an update or whatever if you want to think in terms of SQL. Right, now you can see this is taking a second. The reason why it took a minute is because I don't have all the data there that I need for this specific call, right? What's the bit of data that I don't have contained in the entity object? The Giphy URL, exactly. So that's why it took a second, because the server actually reached out. Thankfully, the internet is working on my laptop, right? So when it was going and inserting that, and we were going and getting this data, it actually had to go and call this Giphy service, which goes and makes, and you can see this is building an HTTP client. It actually reached out to Giphy, got that data back, and attached it to that specific object. Okay? So that's how we did that specific thing. But let's just double check. Did we get a Giphy for this? Yeah. I'm just interested to see what kind of Giphy it pulled back for a Tesla. What? Okay, whatever. Maybe that bit of code needs some work. But anyways, you get the idea. Right? So similarly, we have something else here, another kind of static, well, doesn't go out to the internet, called isCool. So again, if we flip back to our browser, you can see that all these cars are cool, or not cool, or some of them are cool. But we go and essentially just have like a static set or whatever. Okay? But anyways, the point here is that the way that we can build out an API is very flexible. And because we have this nice library like GraphQL Speaker, we can build out very quickly without having to go and add a lot of boilerplate and have extra classes. We can just use annotations to build everything. And if we're interested to see how all this comes together, let's just have a quick look at well, let's start at the top. Here's our GraphQL web configure, right? So if we go look at this, what we're doing is we're using the Spring web MVC configurer right here, right? And we say we're going to add this extra view for graphical. So the graphical like UI that I've been using just to demo this, it's just a jar file. If you drop that jar file into a GraphQL server application, we can very easily expose it like so that we have this testing endpoint as well. And of course, we have to have an index.html, which is the front end code or whatever. But we can have this at this specific location, right? So if I zoom in here, right, you can see that I'm going to slash GraphQL, and that's how we set that part up over here. Okay? And again, you just have to drop a jar file. If we go into our pom.xml and we scroll up, it'll be here somewhere. Hope it's here somewhere. Right? So actually, it's embedded inside of this GraphQL Speaker library. But it's very easy to set that up. And let's finally just have a quick look at the GraphQL controller. So what we do is we say initialize a new GraphQL schema generator. And again, that class is from our GraphQL Speaker library right here. And we'll say use these resolvers, build a new annotation resolver. It'll go and scan the class path, find those annotations, use operations from this service, right? So you saw the car service before, create a value mapper factory. This is just for the Jackson. So that creates our schema. These lines of code and go and create our GraphQL schema dynamically, okay? So we don't even have to go and like do any hard coding or whatever. Now, I didn't show this earlier, but I do want to mention it quickly. You don't have to build everything out in code like this. What you can actually do is, this is from the previous example, using the low-level GraphQL Java library. All right, we can actually go and write out the actual schema using the GraphQL schema format, which is this stuff right here, right? Or if you're lazy like me, you just say, you know what, I'm just going to go and annotate all my stuff like so, and you go and build the schema for me because I don't want to do that, okay? So anyways, we build out the schema, we create a new GraphQL from that schema, and here's our post mapping for the /GraphQL endpoint. And the rest of it is relatively straightforward. We say from the GraphQL schema, go and execute that new query based on the input that was provided. Okay? And that's how we build out a GraphQL server in Java using this specific library. All right? So let's just make sure we've covered everything here. I think we have. I'm going to just skip over these slides. I only have a couple of minutes. But with this, using either GraphQL the GraphQL Java library or the GraphQL Speaker, you can build out a GraphQL server like we did here using Spring Boot, or if you use MicroProfile, you can use MicroProfile or whatever, right? And actually, you may have noticed earlier that inside one of these applications, which one was it? Right, if you want to also build out something that just runs from the command line, you can see, has anybody written a Spring command line app before? Anybody? A few people, yeah. So this is just the standard Spring command line runner object. So you can actually write a GraphQL like program, not a server in this case, by just going again and using this library. Okay, so let's go back to here, get back to our slides. Okay, so we've covered pretty much everything you need to know, but there are a couple of things that we haven't covered. For example, authentication and authorization. How do you do that against GraphQL? Unfortunately, we don't have time to get into all that, but you can find some examples out there which walk you through setting up authentication and authorization. It's not very difficult. It's what you would expect. We also didn't get too much detail into features like pagination. Right? I showed how you can just get the first one or the first two or last one, last two in an earlier demonstration. But the thing to note is, for example, when you want to do pagination, when we're building out a GraphQL server, we have to write everything. Right? You saw me add annotations to the car service and to the car object. So when we're doing that, we're basically building out a GraphQL server. So if you want to do pagination, you have to have the ability inside of your entity object or your service object to go and get paginated data, right? So it doesn't come for free. That server-side stuff doesn't come for free. You have to still have the ability to do pagination, and then GraphQL allows you to expose that pagination into the GraphQL library, okay? So we didn't cover pagination in our code examples here. We talked a little bit about mutations and changes and updates, but we didn't get into too much detail on that either, unfortunately. So I'm going to stop there because I have about 20 seconds left. How much time do I have left? Am I done? No more time? Oh, keep going. Okay. Thank you.